So what we're going to do today is we're going to create this crank assembly. We're going to use the bottom-up assembly technique, which means we're going to start off with existing components and then just put them into the assembly and relate those components to each other using assembly mates. Okay, so what we're going to do first is we're going to create a new assembly. So once the assembly has opened up, you'll see that it prompts you on the left-hand side to browse for existing parts or assemblies to add into your assembly. In this case, we're going to browse and find the bracket. The bracket is the main part that all the other parts are going to be attached to, so it makes sense that we put that one in place first. Now, what it will do is it will prompt you to place the component somewhere. If you just click there, it'll place it fairly randomly. If you go over to the left and hit OK, it will place this component directly over the origin. So if I just show origins, you can see the origins there, and what it will do is it will place the component over the origin of the assembly. Okay, if you look on the left-hand side, you'll see there's an F next to the bracket. That F means that this component is fixed. So if I try and move it around, I won't be able to. There are two states with components in an assembly. They can either be fixed or floating. I don't know how you remember which F stands for whether it's fixed or floating, but it does stand for fixed. So the next thing we're going to do is to insert another component into the assembly. There's a couple of ways of doing that. You can either select the insert components from here, or you go up to insert component on this on the drop-down menu tree. So whatever way you do it, just select a new component, browse for that component. The first thing we're going to put in place is the wheel. So if you select the wheel, hit open. Now again, it's prompting you for somewhere to put this component. The best thing to do is just to leave it away from the rest of the assembly and just click. Wherever you click is where the component will be dropped. But if you'll notice, if you then hit escape and then select the component again, and you can find that you can drag it around to wherever you want. That's a way of temporarily getting a component close to where you want. But what we really need to do is to link these components using what's known as assembly mates. And our assembly mates just make relationships between bits of geometry on two different parts so that they're aligned with each other. So for example, the pin that goes through this axle that goes through the wheel will be located in this hole here. So the way that we do that is we select the face of this hole, and we select the face of the axle. Be very careful to make sure you select the faces and not edges, and then we select the mate command. Now on the left hand side you'll see that it will be prompting you for the faces that want to be mated together. Once those are selected, what it will do is it will try to work out what the most logical type of mate is to be selected. In this case, because we've selected two cylindrical faces, it's decided that concentric is the most logical mate relationship. So by concentric, that means that the two concentric, that simply means that they share a common center, and those cylindrical faces are now lined up. There are other options. We could have tangent, so if I select tangent, so you'll see that the component moves slightly, and I'll just perhaps demonstrate that. So that's the tangent mate, and that's the concentric. So once you've completed that cylindrical mate, if you try dragging the wheel, you'll find that the wheel can rotate and it can move in and out, but it will always maintain that cylindrical concentric mate relationship. So the next thing we need to do is we need to make a mate relationship between this face here and the back face of the bracket. So if you control select both those faces, go to mate, what it will do is, again, it will assume that you want to make a coincident mate. So coincident simply means that you've got two surfaces, two faces that that coincide with each other, hence coincident. So hit OK, and now you'll find that that wheel is now positioned, and it's still allowed to, it still can rotate, but it's positioned in the right spot and concentric with that hole. So the next component we're going to put into the assembly will be the connecting rod. So again, go to search for the component, select the connecting rod, and again, just the easiest thing to do is to drop that on a spare bit of space away from everything else. And what we want to do next is to make that face there and control select that face and make a mate relationship between those two faces, make that coincident, and hit OK. We're going to spend a lot of time now just creating mates, so I've just selected those two cylindrical faces, create a mate between those two, and now we'll find that we have the ability to move this, but of course the connecting rod is only attached to the wheel and nothing else. So the next component we want to put into the assembly is the little component that goes backwards and forwards, which I've called the shuttle, and that's this little yellow component. So again, plonk it there. This time round it's actually put itself the wrong way round into the assembly. So what we want to do is want to make a relationship between that face and the inner face of the bracket. So if we go to mate, you'll find it just moves to where there's a coincident mate between those two faces, but that's around the wrong way. That's not what we want. We want the reverse of that. So if you go to the mate alignment tab here and select that, you'll see what it does is it just turns the mate around the other way. So to show you that again, just flips the mate into the other side, which is exactly what we want. So the next thing we want for this component is we want to have a relationship between that face and this face here, so that it'll slide backwards and forwards. So we do that, and there we have it. As a general rule of thumb, if a component has two mates on it, it will allow some degree of movement. Generally, if it's got three or more, it's quite restricted. Not always the case, but as a rule of thumb. So now we just want to make a relationship between these two cylindrical faces. So again, go to mate, and there we have the slider positioned. So now if we rotate this, you can see that the components move exactly as wanted. If any of those mates were missing, then things wouldn't run smoothly like that. Okay, a couple more components to insert. So if we go to bring in the cam, that's probably the next one, put that in place. I might just go straight and put in the final component as well, which is the cam follower. So open that up, and that goes there. So the little cam piece sits on the axle of the wheel. Now you can see there's a little flat, so that little flat needs to be aligned with that flat there. So you select both those two faces, go to mate, and that's got a coincident mate, and then we go to the cylindrical faces, and we have a concentric mate attached to those. And then the final thing is these two faces want to be coincident, and there we have it. So the final component to be mated in place is this one. Now this pivot hole goes over the pin on the bracket. Now again, that's around the wrong way, so we need to flip the mate alignment like that. The next thing we're going to do is to make a relationship. Sometimes it's a bit tricky getting the right faces, so we want that face and this face to be aligned. Okay, so far we've just been creating simple mates. This final mate that we're going to put in place is a slightly more complex mate. So down the bottom here we have advanced mates and mechanical mates. What we're going to do is just select a mechanical mate. Again, we've got some options here with cams and gears and rack and pinions and so on. This time we're just going to use the cam, so we're just going to select that cam. And again, it prompts you for a face to relate to, so we're going to select this one here. And then it asks for the cam follower. So the cam follower, oh, sorry, I've done that around the wrong way. The mate selection, you want to select this cam face, and then you select the cam follower, and the follower is this face here. And you'll see that now this these faces will always be tangent. So this is a tangent cam. Okay. So there we have it. Now what we can do is we can grab hold of this component here and rotate it, and you'll see that now the entire assembly moves the way it should move. So there you have it, bottom-up assemblies. The final thing you can do with this assembly is to create a motion study. So down the bottom left hand side you'll see there's a couple of options, two tabs here, one's for model, one's for motion study. If you select that, what we can do is we can add a variety of different things, from springs to cams to gravity, but one of the simpler things is to just add a motor, and this is the motor control. So if we select that, we've got an option of a rotary motor or a linear motor or an actuator. What we can do is we just want to have a rotary motor, so we want to make that wheel rotate to make everything else rotate. So what we do is we'll select a component direction, and you can see there's a little red arrow that tells us that that's the direction we want the wheel to rotate in. We can select the speed of the motor. We can have a constant speed or a whole variety of options. Let's just keep it simple as a motor. Now what we can also do is increase or decrease the amount of time that this sequence goes on. We can have other components doing other things, but let's just keep a very simple one for now. Go to where it says calculate, and it'll calculate what happens with the motion as that wheel is rotated, and there you have it. So there's a couple of options for the playback loop. You can have it so that it just plays back once and stops, or it plays back in a loop, or it plays backwards and then forwards and then backwards. So once you have an animation that you're happy with, you can then save this animation as an AVI file so that you can incorporate it into a presentation.